I'm going to focus on answers to practice test questions that I want to be able to give an explanation for. Then I'll post other solutions just as a document. So here, we've been told this is the graph f of x. In part A, we've been asked to find f prime of 2. That means the derivative of f at the place where x equals 2. Well, there's where x equals 2. And we remember the derivative means slope. So we want to find the slope of the graph of f at the place where x equals 2. Essentially, that means I want to find the slope of that line segment. So I can do change in y over change in x. M equals, that looks like 3 minus 1. Change in the y's over the change in the x's is also happens to be 3 minus 1. And I get that that slope equals 1. Here, I've been asked for f prime of 4.1. That means the slope of graph of f at the place where x equals 4.1. Well, when x equals 4.1, everywhere between x equals 4 and x equals 5, my function is this little horizontal line segment. The slope of a horizontal line segment is 0. So that's my explanation. For part C, I've been asked to find f prime of 5. So here's where x equals 5. I have to notice that the derivative as I approach x equals 5 from the left is 0. That's the same derivative we got when we were exploring at x equals 4.1, because that's that same line segment that's in charge, that's active in the graph at that time. If I want to find the derivative as x approaches 5 from the right, I'd have to find the slope of that line segment, which you could find out. It happens to be 1, but what you need to notice is that the derivative from the left, 0, is not equal to the derivative from the right, 1. I would say this derivative is undefined. And the limit as x approaches 5 from the left, the derivative as x approaches 5 from the left does not equal the derivative as x approaches 5 from the right. Okay, this is the question about Karen. I want to focus on part C. It says at one point Karen turns around because she realizes she's forgotten her calculus homework. At what time does she turn around? We need to notice that this is the graph of Karen's velocity. We know that whenever velocity is positive, Karen must be going forward. In this case, when Karen's velocity is positive, she's bicycling toward school. Whenever Karen's velocity is negative, her motion is backwards. And backwards in this context would mean her motion is away from the school or back toward her home. So we want to notice that the time where she turns around, at what time is it that she had been going forward but then started going backwards? That's the exact place where, there's a big dot right there, the exact place where her velocity changes from being positive to being negative, where the velocity changes from being above the t-axis to being below the t-axis. So for me, that is at time equals 2. So I would say Karen turns around at time t equals 2 because her velocity changes sign. So specifically, you would say because her velocity changes from positive to negative. Or you can just say because her velocity changes sign. So take a look here. This is problem number 13. Remember, we've made a correction on problem 13. Been asked to write the equation of the tangent line to f at the place where x equals 5. Well, to write a tangent line equation, I need an ordered pair. I've been told x should equal 5. When x equals 5, I know from here that y equals negative 7. The other thing I need is the slope of the graph of f, that's f prime of x, at the place where x equals 5. So I'm going to come here to the graph. And that's, can't quite read it, that's 20. So I would write y minus negative 7 equals 25 times x minus 5. Feel free to leave your answer like that.